Hey, hello guys. This is Sudeep. I'm assuming most of you are new, but also a quick intro on what we are going to do today. So today we are going to create something called as smart contracts. Basically, these smart contracts get deployed onto a blockchain, and they help us in running the use case in a very decentralized way. The idea is to uh, create a voting application. The application end of it has already been created by me, and I have also tested it to some extent. But also, uh, the the smart contract is something that we want to develop it here and do this. Before I go ahead and start off with the content, I just wanted to know if you have been able to run the prerequisite. And I had the initial idea was that I'll walk you through a demo. If you had already finished with the MetaMask installation and had your wallets funded. So if you have, let me know in the chat that if you have done with the prerequisite with an yes or no. And based on that, I think I will take the appropriate direction. I will come back to answering that, Mayank. I'll answer this live. Okay, Mayank says no, he hasn't done with the prerequisite. How about the others? Okay, so yeah, there are like 20 and then 19 participants. You can Jai Ganesh, you can always add Matic. Adding Matic is a very simple step. You can just go to chainlink.org and add the Matic network. And once you've done that, you have to just go to the faucet, Polygon faucet to and just copy paste your address there as in the video. That will make it quicker. I had shared Excel sheet, hoping you guys could fill your addresses here. But since I didn't see that, am assuming most of you haven't done that. Okay, so in that case, let's hop on to creating the contract. Okay, so let me I'll share my screen. So smart contract basically is a piece of code that runs on a blockchain. So basically, for our use case, we are going to use a blockchain called as EVM based blockchain called as Polygon, which is a kind of a layer 2 solution for the Ethereum blockchain. Just to make it on the Polygon blockchain, it's easy to do transactions because you can do it at a lower cost, and and also it's very easy to get as many test Matic as possible because in this particular use case, I just wanted to have multiple accounts or addresses with multiple ether funded in it. So for that purpose, I wanted to use Matic because getting the test cryptocurrencies are a little bit easier on Matic. Okay, so basically what smart contracts are is smart contracts is a piece of code that runs on the blockchain. And once it gets deployed, it's basically immutable. So no one can go and change the rules. No one can change the logic of the smart contract. So that provides in a lot of security, kind of brings in trust between parties who don't know each other. So you don't need to trust a third person just for the sake of saying, okay, I mean, you don't need to trust a third party or an individual. You just need to trust the code, the piece of code that is on the blockchain. And in that way, you will be able to use applications in a trustless environment. Okay, so what does blockchain done so far is blockchain by itself has given rise to a huge kind of an economic system called as uh, crypto economics, where basically people can run decentralized businesses across the world. It has also given rise to a concept called as decentralized finance. So let me just show you how powerful decentralized finance is. So decentralized finance is basically a kind of a, okay. So decentralized finance is a very something that's very similar to the regular financial world, where you can like buy cryptocurrencies or like take loans, earn interest rate, and basically anything that you can do in a regular environment. So basically anything that you can do in a financial world can be done in a decentralized world on the blockchains as well. The only thing is you don't need to share your uh, KYC details. You don't need to share uh, uh, your your identity with any of these protocols. Currently, all of these are decentralized and without any kind of a KYC. And as you can see, the growth of this industry on the chart here, in 2019, it was uh, like around thousands of dollars, like $180,000 or so. And currently, and in the peak, it was around $180, $80 billion or so. And now currently we are back in the state where we are in the market is currently at $41 billion. So, and people here get interest rates which are probably as big as like 100% or 102%, and even sometimes 400% kind of interest rates. So this has become a place where people want to go and start investing in and play around with it and so many things. Currently, it's impacted by a lot of regulatory concerns and kind of a downturn. We are in a crypto bear market, to say so. So the values are kind of low. Smart contracts have revolutionized the way people can interact without trusting someone and trusting any third-party business. Okay, so what we will do is we will create and the language that is used in in the Ethereum or EVM based machines are is called as Solidity. Solidity is a simple object oriented programming language which is still in a very initial stages of development. And it's if you're from a programming background, it's quite easy to learn and start using it in the and start finding opportunities with that. There are quite a lot of job opportunities uh, with Ethereum and Solidity smart contract development. So jump on to the QAs. So Mayank Gupta asked, so smart contract, is it a piece of work or a piece of stake? It's neither. It's a piece of code. Okay, so we'll be writing this piece of code and we'll deploy it. But when it gets deployed onto a blockchain, basically to run it on this blockchains and execute all of this, you will need to have some kind of a digital currency. And in our case, we are going to use test digital currencies. But if you have say a cryptocurrency that you would use to stake, which can give you more like earn more cryptocurrencies, and also like piece of work is basically what you called as proof of work, is an consensus algorithm to keep all of these decentralized systems in sync. Okay, but smart contract is neither of this. Talking about a video, can you please share the link of the same? So Mayank, the video is the prerequisite video about how to install MetaMask and how to integrate, how to fund it with some test wallet, test Matic for using this application. It should be available in the prerequisites section. So I think the organizer will be able to share that in the chat. Okay, what is DeFi Llama? So DeFi Llama is a portal that gives you a state of what is happening in the DeFi world right now. So, so blockchain, because of its very decentralized nature, brings in a huge set of digital assets. They are called, you can call them cryptocurrencies or crypto assets. And this DeFi Llama is a protocol that allows you to basically track that. Okay, so if I have to go to the DeFi world, MakerDAO is a protocol which allows you to lend and borrow. Okay, Aave is a lending and borrowing protocol. DeFi, Curve is a protocol that allows you to basically say you already have some cryptocurrencies. Now you can earn interest on them. So this is Curve Finance, which the initial look and feel looks as if it's a age-old Windows button and UI look and feel. But basically what you do is you have different kind of cryptocurrencies and you might want to trade one for another. So that's what you're basically doing here. This platform allows you to swap one cryptocurrency into another. Then there are pools like this, which basically allow you to put your cryptocurrencies in them. And this kind of adds liquidity into the market so that people can swap or buy and sell kind of things. So basically, if you go to a bank and you want to take a loan, first of all, the bank should have amount to lend you, right? And all of this is managed by the regulatory structures and the governments, and make sure that the bank is funded enough, right? But in the decentralized world, there's no bank. There's no one entity who is governing all of this activity of lending, borrowing, and all of that, and seeing who has how much money and kind of things. So all of these are managed in decentralized way, in the decentralized way by individuals like you and me. So when we go and buy crypto assets or cryptocurrencies, we go and basically can go and put into a pool which will earn you, which will add liquidity for someone to go and swap one cryptocurrency into another. Okay, so all of this needs to have to do anything of this, you need to have smart contracts. Okay. So this is completely a financial use case, but in our thing, we will look into more of a voting application to go and use doing voting on the blockchain. Okay, just like the voting that happens. That's just like voting that we do for general elections. Okay, so Mayan Gupta asks again, is smart contract similar to a piece of NSE BSE because it's similar to VB bought when markets are at low prices? No, smart contract is something that enables all of this. Okay, smart contract is a piece of code that allows you to create assets. So in NSE or BSE, basically an exchange, you trade stocks. So they allow you to trade stocks or buy and sell stocks of companies which you are holding on to because you see them as assets or future or assets with which you can earn money in the future, or say you get some incentives when you hold on to that stock, right? It can be either as dividends or either as increase in the stock value, right? But smart contract is something that will allow you to create such assets, but they don't go into NSE or BSE, but it allows you to create platforms that will allow you to trade. So the Curve Finance, the video, the website I just showed you guys where you can swap, is like NSE and BSE, which will allow you to trade assets. Hope that answers it. Okay, and to be able to do that, you need piece of code that will help you run. So whatever actions happen on the UI, you'll have to do it on the backend, on the blockchain. So smart contract is the one that will allow you to do that. Yeah, so let's go to the coding part because this is a Solidity hands-on session. So what I'm using now is an online tool for developing smart contracts. This is the one called as remix.ethereum.org. This is something that most of the people use when they are learning blockchain development or Solidity smart contract development. And post that, you start using your regular Visual Studio Code with development environments, which will help you work a little bit more faster. But nonetheless, you can always use an online tool like Remix and to start things. Okay, so in for our use case, we are going to create an election application where basically there will be candidates who will who will show their interest in running for election, and to do this, they'll have to pay a small amount of cryptocurrency. Okay, in this case, it's going to be 0.1 Matic, which is the currency of this test blockchain that I'm using. The links is shared. Okay, there's a Loom video which in the chat just above. This Loom video talks about what are the steps to do for doing this operation. Then there is a MetaMask, the link to MetaMask, which is a browser extension that you add. Chainless.org is the a website where you can configure your MetaMask to connect to a particular test network. And Faucet is a place where basically you can fund your wallet for testing purposes. Okay, all of those links are shared in the chat. Okay, so coming to the requirements, we'll be creating a candidate who will have to pay a small amount of cryptocurrency to register himself and show interest in running for the election. And since this is a decentralized world, there is no some entity who will say, okay, he'll approve that candidate or not. And this support should come from another person or who basically has address, and he'll say, okay, I will support this candidate as a kind of propose and propose that candidate and say, okay, I want this candidate to run for this election. So once the proposal is complete, then that person should become eligible to start contest in the elections and get votes. And once he is basically voted, and once the election period starts, let's say people can start voting, and we'll be able to see the results as to which candidate had the biggest number of votes and who won the election. Okay, and this should be done only after the election is complete, right? I mean, there is a start and an end period. So only between this period, someone should be able to vote. And after the election gets started, someone should not be able to register himself as a candidate, which makes no sense. So all of these rules can go into a smart contract. Okay, so these are basically the comments, the rules that I'm going to code in. So now let's start off with the coding. So 8.17. So what basically this means is this is a direct. This is like a compiler directive. So in the programming language, you usually tell, okay, you are going to use this piece, this kind of a version of say Java, or this version of C++, and it's also going to. So when you give this information, the way the environment is going to execute it is going to differ based on the version in which you are running. But here, in the case of a blockchain, the blockchain is continuously running 24/7. Okay, but it will allow you to support multiple versions of your program. So you need to specify in each program what is the kind of version, so the code that you're writing, how is it going to behave like? According to which version of the Solidity is it going to behave? So for that, you need to provide the version number. You can provide version with say ranges, adhering to major minor versions and so thing, and so many ways you can specify the version. This is Solidity version. This is the like 0.8.17 is the current latest version. I'm going to use that for this. Okay. Now, just like in any programming language, any object-oriented programming language, there are objects which whose instances you create, and which basically has all the context of that object. It has some defaults. Then when you go and basically it does when you go and do some functionality on that object, it attains some state, or it basically goes through some changes. So in this, the object that object is called as a contract, and very similar to a class in Java and C++. Okay, so we are going to start off with a keyword called contract, and I'll say, okay, I'm going to do an election contract, and so this basically contract is something that will this is the object instance, an election instance that we want to create and go and vote on it. So now let's so what I'll do is I'll copy piece by piece of code from an example that I already have, because I see that this is going to take a little more time than I expected. Okay, so I'll copy individual pieces of code and I'll explain those instead of typing, because typing is going to take some time. Yeah. So and in most of the programming languages, you can create your own data types, right? Using structures and so. So the same thing is applicable to Solidity as well. Here, I'm going to I'm creating a struct called as candidate. I'm seeing if the candidate is already and basically this candidate is going to have some basic intrinsic types like a Boolean and an integer, string, or anything of those types, which will help us construct our own default, our own custom types. So candidate is one of those custom types. I'm just checking if this candidate is supported. So if he is not supported, then he should not be able to be participating in the election, and no one should be able to vote for him. That for maintaining that, I'm using this Boolean, and we are going to use some IDs in the blockchain space, whether it's a smart contract or an individual person. They are identified by something called as an address, okay, which is kind of is unique to each of the person, and one person can have multiple addresses. So we are going to use that to identify that candidate. Then the number of votes that he has accumulated in the period, and what is his name. Okay, so this is basically what defines our candidate type. So so sometimes what happens on a blockchain is when a piece of code gets executed, you don't know the kind of traffic the blockchain is going to have. So it's possible that when you request for some activity, that activity is not that you request for some kind of say get this job done on a normal server. This request can take some time to get processed. So basically, like any service that can take some time to get processed, you handle it through asynchronous events. So you submit a request and come back and wait for the results. Same thing happens in the blockchain space. And in the blockchain space, basically, most of the activities are asynchronous because it involves, because there can be too many activities running on that particular blockchain, which it's not able to consume at that point in time. And it can be very time consuming. So you need to think everything from the asynchronous side. So whenever an activity gets completed, it is reverted back using an event. So what was that event and what are the kind of data that you want as a response from that particular event. So here I'm having events for registering the candidate, say that candidate was supported by someone, and which candidate voted for, so which voter voted for which candidate. To get that data, I'm like declaring some events, which I'll emit it at a later point in time. Okay, so there, when you create some variables in your class, that's basically to hold the state of that variable, right? Hold the state of that particular class, right? And when an object instance get created, each of the object can be of different state based on the kind of variables it holds inside it. So similarly, each object that we are going to create here in terms of the contracts, you're going to store some state. So in the voting application, we are interested in keeping the state of who are the voters, whether they have already voted or not, because one voter should not be able to vote for the same candidate again and again. And who are the candidates who are registered? And how can you get the details of the candidates? Yeah, all of that should be possible. So so what I'm doing here is I'm using something called as a mapping. So mapping is nothing but a data structure which allows you to store the data in the form of key value pair. It's very similar to how hash maps work in Java. Okay, so here the key is going to be an address, and bool is going to show whether this particular voter has voted or not, just keeping track of the voter status. Okay, and this is again a mapping which is going to keep track of the candidate. So given, so I'm going to have a counter running which is going to increment when any candidate gets registered or adds himself for as a candidate for the election. And I'm going to map that ID, that counter with the candidate. A simple way of tracking the candidates. Again, I'm using a mapping. Based on the implementation, people can go and even implement an array. Both of these are feasible. But mapping has a little more advantages in terms of read write is a lot quicker, as you already know. We need some kind of admin activity in our application. These need not be there in a regular application, but for this activity, I wanted to keep an admin whom I'm calling as an election admin or simply an EC admin, who is going to perform some activities like start of the election and stop of the elections. Okay. Then comes the candidate count. This is the counter I was talking about, where I'll keep incrementing the candidate count to keep track of the number of candidates who are registered. A variable to keep track of the start time and the stop time. As against other standard languages, this doesn't have a date type. This is an integer, is going to be an unsigned integer, and the time it's going to track is basically the Unix timestamp. So what is Unix timestamp, you may ask? So since Jan 1st, 1970, our computers are ticking for every second. Okay. So every second there is a tick which marks 1 second. Okay. And this is the number of ticks since Jan 1st, 1970. Okay. And this is what is used as a timestamp on the blockchain. Okay. So that is why it's represented in a unsigned integer number. I have a question. I'll just jump onto that. Is there a YouTube channel where you can get some content regarding crypto? What type of content are you looking for? It depends on that, because there is plethora of YouTube channels, each delivering different kind of content. So if you can be a little more specific, I can help you out. Educational content. So with respect to educational content, there is this guy called as Collins. he's the CEO and co-founder of Chainlink. He has, I think, a month or two back, released a 35-hour content on learning blockchain from the basics till the kind of current use cases, which like one huge set of videos of 25 hours. Yeah, this is Patrick Collins. I'll give his name since I don't have YouTube open right now. So you can see it, right? Okay, so this guy released a video. There are other websites like Learn Web3 DAO, and all of these are like free sources. Apart from these, there are paid resources like Eat the Blocks. I'm creating content for Pesto. So Pesto is a uh, uh, is a is a he has taken the responsibility in one way of transforming Web 2 engineers into Web 3. So whatever we are talking about comes under the concept of Web 3, third generation of web. So all of these technologies that we have right for so far, like the databases, the web, like React, and all of this come under Web 2. And this third generation of web that we are talking about, which basically involves blockchain, and so is so requires some extra effort and extra things that one has to learn. So Pesto is doing that. Learn Web3 DAO that provides free resources, and it's something that you have to do on your own. But if you want some kind of instructor-led help, Pesto and Eat the Blocks are some of the resources. So this timestamp is for the block. Yes. Let me go back to my application. Yeah. So this timestamp is for the block. Going back in. So yeah. So just like any object has a constructor, the smart contracts also can have a constructor, where we basically do some on creation initializations. Okay. So what I'm doing here is I'm taking the person who deployed this contract and saying that, okay, this guy is the admin. Okay. And the time is basically when the block is getting created. So when a block is getting created, at which the contract is getting initialized, that is the time when the blockchain voting can start. Okay, but I don't want to do it this way, so I just I want to start the blockchain at my own interest. Sorry, the election at my own interest. So I'll skip that. I'll copy this later. Just adds a few functions first. Okay. So this first function is about the candidate going and registering himself. Basically, he's going to send his name, and in the transaction, he is supposed to send some amount of cryptocurrency as an entry barrier to go and register himself, to see that, okay, this guy is serious, right? Otherwise, anybody would go and register. In this case, I've just limited that amount to 0.1 Ether. Ether here is more of a denomination here in this case, because we are going to deploy it on Matic. On the Polygon blockchain, which uses Matic as a currency, it's going to use Matic. Here it becomes more of a denomination, just like rupees and dollars. Yeah. So so I'm going to first thing that I'm going to check is if the person has sent the required amount for registration. Okay. And also I can go and check if the candidate is already registered and all of those sort of things, but I'm just skipping that for this exercise, just to keep it simple. I'm going to increment the counter. So I'm going to start with 1. By default, it's going to be 0. Now I'm going to create a candidate object with supported as set to false, the address of the person who is registering as the candidate address, number of votes he has got, and what is his name. Okay, this is something that I'm getting from the function parameter. So I'm going to take that and keep accumulating it in our hash map, which is called as mapping in our case. And once all of this is complete, you go and send out an event telling, okay, this person has registered. Okay, this is what this function is going to do. Basically, public means, okay, it's going to be accessible. Payable means this function is going to accept some cryptocurrency. Okay, basically the currency in the form of gas. The blockchain's native currency. That's what this payable means. Okay, so anybody should be able to register as a candidate. So anybody should be able to support another candidate at his free will. Okay, that's what this does. So support candidate, you are going to specify the counter number to go and fetch him and update its state. Okay. External again is something that specifies that this can be called externally. Very similar to public, but there are some differences which we cannot go into depth in this part of session. But there's a small difference. Yeah, and I'm going to check if the candidate is registered. So I might send an ID which is where the candidate does not there's no such candidate at all, right? So I need to do those checks. So I'm going to go and check if this ID at that number is has a zero address or has some value. If it has some value, that means this candidate is registered. Okay, and the candidate should not be able to go and say, okay, support himself, right? So I'm going to add that kind of a check here. Then you go and support the candidate if he's not already supported. So that is this check. And once I am done with the checks, I will go and say the candidate is supported. I'm going to set the supported attribute to true and send out an event saying, yeah, that this activity is complete. So these functions are simple setter functions. Basically, they are going to set the start time and the stop time. But I want to restrict that this activity is done only by that that person who is creating this election. Okay, so to do that, you need to put in some restrictions, right? I'll have to say if the person who is setting this start time or setting this stop time, I'll have to check for his address and make sure, okay, this is the admin only and not somebody else. So it's like you're repeating the code multiple times at multiple places. So to avoid that, there is something called as a modifier, which basically runs before a function. Okay? And you have to specify it this way. So I'm creating a modifier which is going to run before the function gets called. So if I call set stop, it is automatically going to run this modifier and check if the person is admin and does he have privileges to do this operation. That's what I'm checking here. So once it checks for that, it goes with the normal execution of this particular function. And that is what this the symbol specifies. The underscore semicolon is going to tell that after this is the place where the function's logic needs to be needs to follow. Okay, so this is so I'm going to do that. Put that restriction in for set stop and start stop. Setting the start time, and I'm going to again put some conditions like the stop time should not be something at a time that has already passed. Right, it should be something in the future, and it should be at a later point after the start time. So that's what I want to set. And so should be the start time. Start time should be a time at the at a time that hasn't already passed. So I'm just putting those conditions here and setting those values. Just a couple of questions. So in the blockchain ecosystem, we are required to bear the cost of casting votes. Yes, basically, any kind of execution that you do on the blockchain, any transaction which is going to change the state of a contract. In that case, you have to pay something called as a gas fee, a small fee to include your transaction. For that reason, it's a kind of incentive mechanism for people who are running the blockchain network. And this is how they get incentivized for including your transaction and maintaining the blockchain and keeping it live 24/7. See, again, coming back, the whole concept is decentralized ecosystem. Each of the blockchain, there is no one single party who has all the rights. Okay, so these are systems where everybody has equal opportunities. So and there are a set of people who are running the blockchain nodes and keeping the network alive and maintaining the nodes and keeping the data of all the blockchains, which is like multiple GBs of data. Multiple TBs of data, in fact, thousands of TBs. So all of this data has to be kept, maintained, and all of this. So basically, any transaction that you do, you have to pay a small fee so that the maintainers get incentivized for doing this. That's why everything involves a small fee. Yeah. So anybody should be able to vote, and when they're voting, they are going to give the candidate ID, like basically the number or the counter number, which is when that's how the candidate gets identified. So to begin with voting, they have to check if the election has already started and if it has not ended already. So we are doing those checks here. And once, so if the person who is voting has not already voted, then only he should be allowed to vote. So checking for that, then checking if the candidate is registered and he is already supported. If none of these conditions pass, then basically you exit the execution. Then you don't vote, right? Only if all of these conditions pass, then he should be able to vote. So this guy goes. So once all of these conditions pass, you are going to set the conditions to true. Like you're enabling the voter and said that okay, his vote is already casted. You're updating that state. You're incrementing the count of the candidates, the voting count of that candidate, and send out an event saying, okay, this person has voted this person. Yeah. So now, once all of the voting and say everything is done, you should be able to see the results as to who is the candidate who has won this election, right? So to do that, you need to check for whether the election has stopped. Only then you'll be able to get the results. And once the election has stopped, then you should be able to count the votes and return the winner. And because there are so many candidates, there could be many candidates. So you need to basically run a for loop to be able to check which candidate has the max votes and find that candidate and return the candidate's information. So basic functionality. So this is a smart contract, a simple one, which is coded according to the rules that the voter data is stored in this one. Okay, this is the variable that's tracking it, but on the blockchain, it is available on this contract. Okay, but we haven't deployed a contract yet. This is just a piece of code that we have written. We haven't deployed it yet. Okay, so now let's go and deploy this contract. So this is the environment where you kind of, it's a file browser, you browse the files and code. Then this is the environment where you choose if you're file is compiling successfully and kind of stuff. And this is the place where basically you select the environment where it needs to get deployed. Okay. So we will have to probably extend this call by like around 10 to 15 minutes to show this. So what I'll do is, okay, now to deploy it on a test chain, I need to put this code onto the blockchain. And to put this code onto the blockchain basically means some kind of data is going onto the blockchain, which is going to be stored in the blockchain for its lifetime, right? So again, the people who are managing this network needs to be paid something for doing this activity. For that reason, I'll have to connect it to my wallet. Okay, so this is MetaMask. It's a wallet which will allow you to perform transactions on the blockchain and maintain the basically query, check your balance and stuff. Okay, with respect to digital currencies and assets, everything. So just connecting. Now I established a connection. As you can see, I have like 0.2 like Matic, which is basically I didn't pay for this because this is test. You can always go and get them. Yeah, and I'm going to deploy this. Let's click on deploy. So first I establish a connection and enable that this application, a remote web app, to connect to this blockchain. And now I'm deploying the contract. Ideally, I should have used an EC admin account to do this, but because I need to have multiple accounts funded, I'm going to use the first candidate as the admin and the candidate both, okay, just for easiness of using this. So let me confirm. Okay, so now my contract is created in the blockchain. What we are seeing now is something called as a blockchain explorer. So basically, there are tons of blocks getting created and so many transactions that are happening on the blockchain. So you need to have a view of whether your transaction is, what is the state of your transaction, or what is the state of your contract and everything, right? So basically, this is the address that was used to deploy the contract, and this is the contract address. This is what is going to be my handle to perform any updates on that object of the election. So this is deployed here. Okay. So I'm trying to move my handles here. Yeah. So what you can see below at this bottom left corner is the instance. Okay. So what are the number of candidates? 0. What are the results? There's nothing right now. The start time, the stop time, nothing has been updated. Okay. Because we just started off with this. Okay. So let me click on the start time. Okay, so this has to be something in the future, right? So I'm going to just put a approximate value. So my transaction somewhere is failing. I think I was getting a old value. Let me just refresh this. Okay, I'm just saying, okay, some number in the future is going to be the start time. Okay, confirm. So now I'm changing the state of the contract, right? So I should set that. Yeah. Now, let me put the contract. So this is like the current time, as you can see. I'm going to put it somewhere like 3 or 4 minutes later on. So it not be very much sufficient. Stone. How the clock is ticking right now. So I'll just say 700. I think I'm getting some old values. Yeah, so I put like around 500 seconds later, the election is going to stop. So I'll have to do some things before that quite quickly. So let me first add the candidate. I need to send a small amount of ether. That is like 0.1 ether. Decimal values are not allowed in this UI. So I'll have to give it in the form of like paise. Okay. All the interactions in the blockchain happen in terms of paise. So like the lowest denomination, and that is called as way. So I need to, and that is like 1 followed by 18 zeros. That's how small the lowest denomination is. So I'll need to give that. That's the only problem with this particular UI. Let's say the first candidate who is going to register is ABC. Okay, so this person has registered. Now to change the candidate, again, I'll have to change the address on the MetaMask. I would have ideally wanted you guys to use MetaMask with me on this, but since that's probably not going to happen, I'm going to change the candidate by changing the address. Okay, so I'll switch that, and there is an updated address here. I'm going to use the second address and create the second candidate. Okay, again, I'm sending that 0.1 matic for adding. Okay, so both of my candidates are registered. I can always go and check that. So my candidate at position 1 is ABC, right? And position 2 is DEF. Now I need to basically support them. So let me go and change my address again. Now change the address again. This guy is going to be the first voter. Basically, first is going to say support candidate. Let's say voter 1 is going to support candidate 1. And hit on transact. Okay. Let's say for the so and should he be able to vote? Let me go and check on my Unix timestamp. I have like 200 more seconds. So let me just quickly do this. I change my address. Basically, whenever I'm changing my address, it's equivalent to some other person voting. Now let me go and support candidate. So he's already been supported. So change. Yeah. So currently, none of the candidates have voted, but they have been supported. So let me start the voting because I have like a very short time. I'll vote both of my voters will vote candidate 2 in this case. So I'll just click on vote. Click on confirm. So this transaction has to go through and show me the state. Okay. Now let me let me just query and show you the vote count. Okay. So this count has been updated. Now let me quickly have a check on the time. I think I have very short duration. Yeah, I still have like 90 seconds. So go back. after which I'll not be able to vote. Okay, let's see. I'll change to voter 2. And I'll again vote for the second candidate only. Right. Okay, so I'm querying the candidates and their vote details. Okay, so you can see that the candidate 2 has 2 votes, while candidate 1 has 0 votes. Right. So I can wait for the election results to be announced. And I'll have to wait for like 20-30 more seconds and I'll be able to see the results. Okay, so if I try to query it before that, I will get a exception saying, okay, election is yet to finish. So don't check for the results right away. So let's wait. Okay, so I think this is past my time. Let me go and query now. Yep. So we now have the data of election results. So DEF has won with like 2 votes, right? So this is basically how you can deploy the contract and do things. All the transactions that we did, basically all the transactions that change the state of the blockchain, you can see them here on the blockchain. So what was the transaction, on what transaction, what function was done, and who did the transaction for whom, all of this data can be seen. Okay. So blockchains are basically public and transparent systems. So you can see basically everything, what's going on the blockchain. Okay, I really wanted to show you this. So basically, whatever we did on the terminal here, which is going to, I mean, it's kind of confusing because you have so many buttons and you're trying to do so many activities one after the other. The easy way to do it is have the UI and do things on the UI, but this would have taken a little bit longer time than that one. So I chose to do it there in with respect to interest in time. Otherwise, we can do the same things here and basically connect this application to this contract, and once and you can start doing this transaction here. Okay, this is what I intended to demo. I'll keep the floor open for questions, and if there are any questions, I'll take them. I know this is kind of a rush to learn anything new, but yeah, we are directly jumping onto understanding on a hands-on level without knowing the basics of a blockchain. So it's going to be a huge learning curve. Any questions? Backend depends. So basically, if you're writing small applications like what I have done, you typically don't need a backend because your data is on the blockchain, your logic is on the blockchain as well. But some cases, there are some cases where you don't want to store things on the blockchain, because even storing a byte of information on the blockchain is going to cost you a kind of a fee. Okay, so if you go to any of those transactions that I just did and check for the fees, you will see I'm going to use a small amount of Matic. So anything that is storing on the blockchain is going to cost a fee. So if you're trying to store some huge data, then you don't want to store all of that data onto a blockchain. You want to choose what goes onto a blockchain. In those cases, you'll need a backend to basically connect your database and process data from the blockchain, process data from the backend, the database, and bring it together and show to the users on the UI. To do those kind of things, you'll need a backend. Some of the things, some of the best, most important applications don't actually depend on the backend at all, because here everything is on the blockchain. Basically, it's dependent on the use case. Let me quickly check on the chat. I think I've answered most of the questions. Yeah.